Let's try this again. Welcome to another edition of Polynomials and Factoring. I am your host, Miss B. We are talking about multiplying binomials. We're going to multiply them by another binomial as well as a trinomial. So our objective for this section is to multiply two binomials and to multiply a binomial by a trinomial. So to find the product of two binomials, that should be number 2, my bad. So to find the product of two binomials, remember binomial means two terms. You can use the distributive property. Been using that a lot lately. You guys should be pros. So you can use the distributive property. So for our first example, what is a simpler form of 2x plus 4 times 3x minus 7? I'm going to distribute every term from my first polynomial or binomial, either will work, times every term in this next binomial. So I'm going to multiply 2x times 3x minus 7. So we'll write that here. We're going to share that term with our 3x minus 7, and we can't forget our 4. Our 4 went in on it too. So 4 times 3x minus 7. So every term gets its part in the party. So now I'm going to distribute 2x across my binomial. So 2x times 3x, 6x squared. Remember, use the product rule here. We have a power of 1 times a power of 1. We're going to add those exponents and multiply the coefficients. So 6x squared. Now I'm going to distribute that 2x times negative 7, which is a negative 14x. Now I'm going to distribute 4 across my binomial. So I have 4 times 3x. That's a 12x. 12x. And I have 4 times negative 7, that is a negative 28. So I need to clean this up a bit. I can further simplify this polynomial by combining like terms. I have a negative 14x, and right here it's a little sloppy, but that says positive 12x. So I'm going to combine like terms. 6x squared. Negative 14x plus 12x is a negative 2x minus 28. I would like you to try this next example on your own. Use the same process that we used above. So, in sum, when you use the distributive property to find the product of two binomials, you multiply each term of the first binomial by each term of the second binomial. All right, let's move on. So instead of using the distributive property, you can also make a table. So once again, we're finding a simpler form of two binomials multiplied together. So I'm going to write them on top of my table. So first I have x minus 3. I'm going to write my x and minus 3 here. And then my 4x and minus 5 up here. It does not matter. You could have put 4x minus 5 down here and x minus 3 up here, as long as your binomial is with its partner in the same either vertical or horizontal sections of the chart. So now I'm going to multiply using this chart. I'm going to multiply x times 4x. I'm going to try to highlight that for you. There we go. Maybe. So I'm going to multiply x times 4x, and that answer is going to go right here. So 4x times x, and I'm also going to multiply x times negative 5. Once again, we're using the distributive property. It's just in a table format. So I have 4x times x, which is 4x squared. And then I'm going to multiply x times negative 5, and I'm going to put that product right here, negative 5x. So now I'm going to multiply negative 3 times 4x and negative 3 times 5. I'll use a different color to highlight that. I'll multiply negative 3 times 4x and negative 3 times 5. So negative 3 times 4x, that is a negative 12x. And negative 3 times negative 5, that is a positive 15. Now I'm going to write out what I have in standard form. Remember standard form, my exponents are in decreasing order. So my largest exponents are on the left, and my smallest exponents are on the right, with my constant with no variable furthest to the right. So I have 4x squared minus 5x minus 12x plus 15. I'm going to combine like terms. I have 4x squared negative 5x plus a negative 12x, that is a negative 17x plus 15. Totally made an error on my paper. Fix that right now. That should be a negative 12x, so that will be a negative 17x. Whoops. So, final answer, 4x squared minus 17x plus 15. I multiplied each one of my terms by each one of my terms. Everybody got to join the party and have fun and mingle. We have our final product right over here. So, I'd like you to do an example on your own. You can either choose to use the distributive property from the front page, or you can use our table method. That is totally up to you. We have yet another method of multiplying two binomials. Remember, these three methods are for multiplying binomials only. So both methods thus far have involved the distributive property. There is one last method that involves the acronym FOIL, which also involves the distributive property. Go figure. So the F in FOIL stands for the product of the first terms in a binomial. Emphasis on the first, the F part of the first. O stands for the product of the outer terms of our binomials. I stands for the product of the inner terms. And lastly, the L represents the product of the last terms. So FOIL, think of first, outer, inner, last. So let's use our foiling method to find a simpler form of the product of these two binomials. So we have the F, that stands for our multiplication of the first terms in each binomial. So we are going to write maybe product of the first terms. I'll get rid of that way we have some room. So the product of the first terms, we have 5x times 2x. That will be 10x squared. Next, we're going to multiply our outermost terms of each binomial. So the outside. So we will write product of outer terms. So 5x times 1, that is just 5x. Next, I'm going to multiply my innermost terms, which are negative 3, and 2x. So product, forgot to stretch it, product of inner terms, so negative 3 times 2x, that will be a negative 6x. And lastly, we're going to find the product of the last terms of each binomial. So the product of last terms, which is negative 3 times 1, which gives us negative 3. So FOIL is essentially an acronym to help us distribute each and every one of the terms from each of our binomials. So first terms, outer terms, inner terms, and last terms. It's just a way to organize our distribution to make sure that every monomial is multiplied by a different monomial in each one of the monomials within our binomial. So now I'm going to write in standard form my products. I have 10x squared plus 5x minus 6x minus 3. We're going to clean that up a bit. I'm going to combine like terms. So I'll have 10x squared minus 1x minus 3. This is personally my preferred method of multiplying binomials. So right now you have 3 different methods, and all 3 methods are acceptable for use. So on an exam, a quiz, practice problems, what have you, you may use any one of these forms. So you have some practice problems to do within our notes. You have A, B, and C. So you can use any method you choose for these 3 practice problems. Go ahead and complete those on your own. So next, we have a pretty lengthy word problem. So a cylinder has dimensions shown in the diagram. We have the radius, which is x plus 1. And we have the height of a cylinder, which is x plus 4. We don't know the exact dimensions. They were given to us in binomial form. Be nice if they gave us the actual dimensions, but we're going to practice multiplying binomials. So, which polynomial in standard form best describes the total surface area of the cylinder? So, the total surface area of a cylinder is given by the formula 2 pi r plus 2 pi rh, where r is the radius of the cylinder and h is the height. So, I have all the information I need, believe it or not, to help me find the surface area with our given formula. This might get a little messy. I'm writing a lot with my marker, so please bear with me. So, surface area equals, we already have our formula. Now we're just going to plug in what we know. We know the radius. Radii, I think, might be the plural. Not sure. Look that up. And we have the height. So, I'm going to write down 2 pi. Now I'm going to substitute my radius in for r, which is x plus 1. Per our formula, that is squared, plus 2 pi, going to substitute r in again, which is x plus 1, times h, our height, which is x plus 4. Looks super complicated. We have just a couple of binomials to multiply, and then we'll be done. So I can't do anything with this 2 pi yet, but I have x plus 1 squared. So I'm going to multiply x plus 1 2 times. Remember, raising something to a power means the number of times we're going to multiply, either a monomial, binomial, constant, what have you. So I have x plus 1 times x plus 1, x plus 1 squared. I can further multiply that to x plus 1 times x plus 1 plus 2 pi x plus 1 times x plus 4. Now I'm going to find the product of these two binomials. You can use any method that you would like. I'm going to use the FOIL method of distribution. So 2 pi, I'm going to multiply my first terms for that f part of FOIL. So times x squared, outer terms, just 1x, inner terms, plus x, and my last terms, which is plus 1, plus 2 pi, can't do anything with that yet. And now I'm going to take the product of my binomials using the FOIL method of distribution. So first, x squared, outer, plus 4x, inner, plus x, and last terms, plus 4. The air conditioner in my room kicked off, so it must be 5 o'clock and time to go. But I'm staying here. Now I'm going to clean up my products. So I'm going to combine like terms and make sure that they are in standard form. So 2 pi times x squared plus 2x plus 1 plus 2 pi times x squared plus 5x, 4x plus x, 5x plus 4. Now I'm going to combine like terms from my products. So to do that, I'm going to multiply 2 pi times everything instead of having 2 pi's, even though 2 pi's is totally better than 1. I want to simplify and clean it up a bit. So 2 pi times x squared, I have 2x squareds, so plus x squared, plus 2x and 5x, so plus 2x, plus 5x, plus 1, and plus 4. 4. Now I'm going to combine like terms. So 2 pi times 2x squared plus, not 7, Miss B, that would be 10. No, it would be 7. I've been here too long. 7x plus 1 plus 4, 5. So let's go up top and see if we have an answer similar to that. We don't. They want us to distribute that 2 pi. So we have one more step. You guessed it, we're going to distribute that 2 pi to every monomial within this trinomial. So one last step, we can do it. I just want to extend my page. Thank you. All right, so 2 pi times 2x squared, 4 pi x squared, 2 pi times 7x plus 14 pi x, and 2 pi times a positive 5 plus 10 pi. Let's check the top. Oh, thank goodness it's there. Choice C. So our final product, our total surface area represented by a polynomial 4 pi x squared plus 14 pi x plus 10 pi. This looks a lot uglier than what it really is. It was just a lot of writing. So if you guys can do this, you guys are all set. But I think you may need a little bit more practice, and we can certainly do that in class when you're doing your practice problems. So good job. We are almost done. Next, we're going to talk about multiplying a binomial with a trinomial. So you can use the FOIL method when you multiply two binomials. However, when you multiply a binomial and a trinomial, you can use a vertical method to distribute each term. So remember when we were adding and subtracting polynomials, we were lining them up vertically. We're going to do the same for when we multiply. So for our first example, we have a trinomial multiplied by a binomial. So remember way back when, either in elementary school or in middle school, where you had to multiply without using a calculator? Hopefully you remember. Oh my goodness. Stand by. Oh my goodness. Sorry about this, guys. Okay, hopefully we're back to working order. So sorry. Give it one more second. Phew. All right, just a minor glitch. It happens. So I'm going to multiply like I did way back when, the old-fashioned way. I'm going to multiply -7 times -5 to get a positive 35. I'm going to multiply -7 times a positive x, which is a -7x, -7x, and this was a positive 35. And next, I'm going to multiply -7 times 3x squared, which will yield a -21x squared. So now I'm going to multiply 2x times 5. So we'll pretend that this is the tens place. So we're not going to write that down right here, only because we're no longer going to have a constant, we're going to have an x term. So to keep us nice and organized and in standard form, we're going to move over a place value, or what we used to know as a place value. So next I'm going to multiply 2x times negative 5, which is a negative 10x. I'm going to multiply 2x times positive x, which will give me 2x squared. And last, I'm going to multiply 2x times 3x squared. And that will produce a 6x cubed. And I'll separate that with a positive number. Now, just like multiplication, we're going to add our like terms. So nothing to combine with 35. I have 35. I have a negative 10x plus a negative 7x, negative 17x. I have negative 21x squared plus 2x squared, negative 19x squared, and nothing to combine with my 6x cubed. So we'll leave that as 6x cubed. There, we multiplied vertically. So our final product, 6x cubed minus 19x squared minus 17x plus, put that plus there too, 35. It's nice and cleaned up. It's in standard form. I have no like terms to combine, so I am all set there. I have one more for you to do on your own in the notes section, and then you're going to have some practice problems. I will be in class to help you along the way. I hope you enjoyed this video number 3, and we'll see you in class. Take care, guys. Bye-bye.